So we're going to move on to Sergio Maggioni. He is the mastermind behind NEUNAU or NEUNAU. I think that's how to pronounce it. It's an artistic sound research project born in Val Camonica in Italy in 2015. The artist's namesake is engraved on a rock in Loire, a place of worship from the Iron Age. So NEUNAU investigations began with detailing a sound source expression, first capturing and then exploring the sound to compose audio tracks, documentary films, specific performances and installations that tell the story of the sound origins. In 2020, Sergio became the lead artist of, I'm not going to try and say this in Italian, Sergio, because I'll just say something horrible, but translated, it's called A Sound in Extinction, an experimental research project that monitors the implications of climate change on Alpine glaciers through sound analysis in collaboration with universities, institutions, and partners. So this is moving away slightly from our usual, it's all about wildlife. You know, we can do other things. It's an artistic approach, and I'm really looking forward to this presentation. So I shall hand you over to Sergio.
Hi, everybody. My name is Sergio Maggioni, and I'm a sound artist from Italy. For several years, I had a sound research project called NEUNAU. The name is engraved on a rock in Loire, a place of worship from the Iron Age in the valley where I'm from, in north of Italy. My main interest is to investigate the relationship between man and nature, so I like to physically go where this relationship is more evident. I collect all the sensations and I recollect into my work of art, such as sound installation, experimental music, performance and documentaries. In 2020, I started a new exploration on Alpine glacier in collaboration with several universities. The name of the project is Un Suono in Estinzione, in English, a sound going extinct, and it's a scientific and artistic project that's aimed to raise awareness on the impact of climate change on Alpine glacier through sound analysis. The project has 3 phases. First of all, we hike to the glacier with an expedition team in order to collect data. But how? Well, we set up the wildlife acoustic recorders, 1 sound meter 4 and 3 sound meter mini, because they are very light and also the quality of the sound is very important to us. And this equipment have a high quality. Plus, they can record the temperature as well. So, we put the recorder in different points of the glacier, inside of crevasse, inside of molein, in contact with ice, near the glacier front, or near the waterfall to record the melting noise. We record sound and temperature 24 hours a day for several months. This phase is physically really intense. Now I'm gonna show you a video of us setting up a recorder in a crevasse.
Dobbiamo riuscire a calarlo per così. Ma questo rumore si sente è sotto? Però è continuo, vabbè.
Sì, no, no.
È uno...
Va benissimo.
Vai, 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 vai. Ok. Così è sospeso. Perfetto.
Then we move on the next step. We analyze the data from a scientific point of view, which our special software we create specifically to be able to analyze such a big flux of information. Alessio Degani will explain this better later.
Hello everyone, I'm Alessio Degani, I'm a digital signal processing engineer and I'm in the Un Suono in Estinzione project along with Sergio since the beginning. My role is basically on the technical side, and today I would like to tell you how we used the Wildlife Acoustic SM4 and SM4 Mini deployed on the Adamello Glacier in order to collect data and elaborate audio stream in order to assess the health state of the glacier itself. We deployed the SM4 recorders using the battery power with a mission time of approximately 2 months. We use SD card for storage, a combination of 512 megabyte and 1 terabyte SD cards, and we continuously record in 24 hours and 7 days a week. That means that approximately we have a data rate of 10 gigabytes per day. Here a photo of the recorder on the glacier that it's about to put in a crevasse. The SM4 can log also the battery voltage. This is a very useful data to have in order to be sure that the battery was sized accordingly. We made 2 acquisition campaigns, one in the summer of the 2021 and one in the summer of the 2022. In the first mission we capture approximately 200 hours of audio data, while in the second expedition we gathered almost 5,000 hours of audio data. So what we do with this audio data? We extract some audio features from the digital audio. The digital audio are recording files of 13 minutes or 1 hour long. The audio features are calculated for each file, so each chunk is calculated separately. Then each chunk is time-stamped and concatenated in order to form a single global representation that basically is a representation that spans 2 months. For doing this, custom software has been developed, and it's used both for audio data analysis and for data plotting and graphing. So the first audio feature that we use is, of course, the kind of spectral analysis that is called the short time Fourier transform. Using the short time Fourier transform, we calculate some spectral feature. The first is we do a subband decomposition. So we decompose the audio data in 3 frequency bands that we call low, mid and high frequency. And then we calculate some feature that is called spectral flux and spectral centroid. There are some audio indicator that tells us how the audio data behaves. So we found that the most important feature for our needs, it's the sound pressure level aggregated for each subband. So that means that we have three spectral bands, and we calculate the average sound pressure level for each band. Here we can see the aggregated plot. So that is the daily sound pressure level. So the x-axis is the hour of the day, and the y-axis is the day itself. So here we have a plotting of the sound energy. Basically, the color intensity is the audio pressure, the sound pressure level. So the darker is the color, it means that the sound pressure level is low, and brighter the color means that the pressure level is high. So here we can see the 3 audio band, and almost we can see here one thing that it's quite fascinating, that it's the what we call the breadth of the glacier. It's better to view it in that graph. That is basically an average of the previous graph, and here we can see the breadth of the glacier. That means that in the time around 60 p.m. The sound pressure level on the glacier is high. Well, it's at its peak, while in the around the 9 or 8 in the morning we have when the glacier is basically silent. So the difference in the sound pressure level means a lot of things.
This information is extremely important for glaciologists, because this is the only way to acquire this type of data, which classical method cannot. The last step, we share the data on 2 different levels. We publish the result on scientific magazine, and also we bring the data to general publish through artistic and educational work that can address the issue on the impact of climate change on a sensory level, because sound goes straight to people's emotion, give a sense of urgency in taking action now. 2080. This data is the reason why I started this research. According to University of Brescia, this is the years when Adamello Glacier, the big glacier of Italy, will completely disappear. To me personally, this is a great loss, because I grew up in this area and I sense it, watch it, experience it since I was a child. This image can give us some perspective on the hugeness of the place. Now I'm gonna show you a video on the rapid retreat on the glacier in a 2-year span. This rapid retreat inspired me to come up with this project, and with this sentence we sum up with my artistic vision of the issue. The melting of the glacier is unstoppable noise that will cause silence. The power of this noise is so big that you can hear in from 5 or 6 kilometers. Our project in number can be summed up with 3 data acquisition campaigns for a total of 9 missions. We use 5 wildlife recorders. We hike 140 kilometers for a total 12,000 meters of elevation gain and 14,000 hours of sound records. We customized the case of wildlife acoustic recorders adding our logo, this year's with a special edition in memory of Gianni Pavan, an Italian pioneer in bioacoustic. At an altitude of 2,800 meters, we recorded a minimum temperature of -5 degrees, or 23 Fahrenheit, and a maximum of 17 Celsius, or 63 Fahrenheit. We recorded and categorized different types of sound. And now you hear the breathing of the glacier, which is in fluctuation between night and day. When it's colder at night, the sound is weaker, while with hotter temperature during the day, the sound gets louder. And this sound is the subglacial stream, a huge river that flows at the base of the glacier. There are two types of discontinuous sound. Big sounds generate from the collapse of the glacier front or from movement of glacial mass. Small sound generate from a reaction of air bubbles which are trapped inside the ice. When the ice melts, there is a change in pressure, making the bubbles escape and creating this sound. In this audio, you will hear the collapse of those crevasses. This is a spectrogram showing the phenomenon of dynamic movement inside the glacier, and we recorded it inside a crevasse. This next one show a small sound. It's a very unusual and evocative sound, as you can hear. This is definitely the most unexpected sound. You got it right, it's an insect. In a crevasse at an altitude of 2,800 meters. We have some future projects, of course. We are planning on hiking more Alpine glacier, bringing the new data collection and analyzing to Greenland and Iceland. Thank you very much for your time.